Bismillah, Assalamualaikum warahmatullahi wabarakatuh. Thank you for the icast 2024 that give us time to present our article under the title The Initial Train of Plain Ground in Light with Bridge, the Precast Concrete Line. We came from State Polytechnic of Jakarta, Civil Department Civil Engineering. I am Pratikto and also with Ani Siswawati. Uh, our article is we have 7 points here from the introduction, main goal, previous research, the model, research method, result and discussion, and conclusion, and also applied model. Our background here starts with the needs of the society in residential building. Nowadays, that what is done by the developers, the housing is developed vertical upward rather than the horizontal. The structure also must be strong, thick, and practical. In the several methods, you can see that in a residential house, the lightweight bricks for floor slabs combined with the steel profile like an angle section and also tunnel section, so that this make the cost is very high. Essentially, you can see that the methods can speed the project, but you choose which the methods that have little cost or can reduce the cost. Yeah. Then our main goal here is to obtain the dimension and cross-sectional of the shape of the system floor slab segment with the initial frame from pen bar 10 millimeter. And then second, we obtain the serviceability of the precast that with big segment, sequences segment, yeah, with the specification from the load and deflection. Our previous research here, we have noticed that we have the data from the lightweight concrete with the segment 25, 20, and 12 centimeter. The strength is 20.61 MPa. This model concrete plate segment produce a large self-weight. Another lightweight base use the 20 by 10 centimeter, but the strength is about 4 MPa. And the concrete cross section only withstand the pressure force, tension and compression, tension at the bottom, and the compression at the top of the section. Another reference, another previous research in the 2016, we have also tried concrete precast in residential house, and we published the archives. And also we have support from, we use the Dakraton in the patent from number 20, 28, 17, 08, 03, and 86. And there is another reference from the SNE. Then the model, we use the simple beam, yeah, as a slab. This is a pen used from 0.9 meter and 3 meter. Analysis of the cross-section with the eccentricity is about 25 millimeter under the cross-section. And the span we use here 0.8, 0.9 meter or 900 millimeter. We have a bending moment here and we have shear force. We see that the chart from tension of plane bar, result of the test tensile, we have crashed in 103.14 MPa with strain and 1.25%. So we give the elongation is about 22 millimeter. Then divide 2 by 11 millimeter. Each of the beam we make 11 millimeter strain. Such with 11 millimeter strain. So the step of the visual method here, from the section we have coacan. It's about 20 millimeters at the bottom of the top and the bottom, and this for base pin bar 10 millimeter. And also we have hole in the middle of the cross section 25 millimeter under the middle, to give the initial strain. And the specified, another specified here is the load required by SNE, like load 1.92 kilonewton meter square, and the deflection not achieved that span divided by 240. The result of the test of the beam, the first crack at the beam occur at the third span of the middle of the beam. That indicates that the poor bending moment occurs at this bending. Some example, another example with the span of 3 meter, but this is not for inertial strain. In this table, you see that the displacement with the strain and also displacement without strain. In the without strain, for the span 0.9, we have load 2.7 but in the with strain, the loads for the beam 5.40 kilonewton. This is about the relation about displacement and the span. So the conclusion here is that based on the testing of the series of lightweight bricks with the dimension 20, 10, 60 with FC prime or MPa and the span between 1 and 3, along with plane bars diameter 10 millimeter, the installation system of lightweight bricks assembled with the mortar and with the lightweight is effective. Installing this as a floor slab in a residential home is reasonable, and the cost particularly is 1.22 kilonewton meter square for live load. This is not surface the upper bounds allowed by the coach, named like span divided by 240. Then finally, the English of the ability elastic bridge series to withstand deflection, we can use 10 mm plane bar stretch with 22 mm stretching on a series line of 9 100 millimeter as an example type. This is the application in the project in the residential house. So in this time of this session, we thank to UP2M and the state for the and also the student of the civil engineering department in the Jakarta State Polytechnic. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Iya, mana ini?